Soldering iron. I am going to talk to you guys briefly about what we're up to now. Unfortunately, I had just shot 2 videos and then followed it up with a third over the last 24 hours, all on the next step of this process. So what I will say to you is that there are a lot of steps to the process, and what I'd like to do is just kind of walk you through them. Okay, so unfortunately, the first video I did was kind of an important one for you guys, and it's one I had intended to share. And it was so important that I want to redo it. The problem is I can't now. It's not physically possible for me to redo it. So I wanted to show you guys something. So this is some of the mods I've made. I even flipped the light over so it's not hanging out over the side to keep this much better weight distributed. And it is, if it weren't for the connector. When the connector is actually laid where it's supposed to be, it's actually CGs very nicely side to side. You can feel it. And it doesn't really CG very far back. It actually CGs right about in the middle where it ought to, which is really nice. So one of the reasons that I want this is because for this particular build, the weight distribution on the board is actually really important. So what I'm going to do is I'm going to show you an exact replica of this particular setup, meaning I'm going to show you the exact same board without all the changes. Now, I showed in the video that got deleted all of the pieces that come off of here. So we've got the on-off switch, and you can see that. So if we put it in the same orientation, you'll see what's been done here. All of these casings, they were only about 0.1 of a gram each. All of those together made 0.2 of a gram, if I remember correctly. This was 0.45, I remember specifically. This took off 2 grams, but then I added a gram with this connector and the wiring. And in the end, this came out just barely 3 grams, and this is 4.5. Doesn't sound like a big difference, but it is. More to the point, this one is heavily weighted this direction, whereas this one I could literally set up in any orientation that I needed to, particularly front to back, which is good because this will all be folded underneath the wing of the plane. This will sit on the front of the plane, and this will stick out the back wing, so that because a plane is mostly facing away from you or up, this will be the perfect setup for that. So there's a couple of bypasses that need to be done on this board if I want to run it the way I plan on running it. One of those is the on-off switch. So when you look carefully at this on-off switch, you notice there are 5 pins here. And when I remove the on-off switch, which isn't very difficult, you just need to heat the pins in the back. And then while you're heating the pins, get your pliers or a tool that you can fit underneath like I did and pry it. And all I used for that, guys, was this guy. Little thin nail file screwdriver kind of thing on the tip. It's nice because you can just pry it up and then lift. And so that's what I did. I also used this. These are really handy for prying up electronics because you can get 2 tips in there and you can spread them apart and get them to right where you need them. You also have the ability to lengthen the spar. So you can loosen this and pull this out, guys. And when you do that, yeah, it's kind of better. So I would, of course, have to... oh, no, this is one of the fixed ones. Okay, oh, no, it's not. I just have to put it very carefully in place and then adjust it. But by doing this and just tightening it, you can lock this in wherever you would want it to be. Now, in my case, I'm not too worried about it. I just leave it as a really sharp point, guys. That being said, those are a couple of the tools I used. Of course, a good set of wire strippers right here are good to have. A soldering gun, a little bit of solder. That's about all you'll need for this, guys. And what you're going to do is you're going to remove the on-off switch if you wanted to lighten this board. Removing all of these is 0.7 of a gram, guys. And when you remove that kind of weight and then snip it here and realize that this is almost 1.5 grams, you've saved yourself a lot of weight. Now, in the end, the whole thing that I saved, even after the replacement, this one just barely weighs 3 grams. It ticks just over. This is 4 or 5. So that's all well and good, but one of the connectors you will see here is a 5-pin connector. Now it's not like this one, where the on-off switch has 5 pins in it, but the N2 are not electrical connections. They are just the pins that hold the board in. As you can see, they're attached to the physical frame of this right here. I'm going to show you the other one here, and you'll see that this has been removed. The post holes have been ignored, and I've filled the 3 in together. What that does is it's called a bypass. What I have done is bypass this circuit by making it permanently open by connecting these 3. So that brings us to our second bypass. This is the second bypass that needs to be done, and it needs to be done because these boards are made to work with onboard gyros. And the way that will work is that the gyros are going to have to talk to the servos to be able to control them. If the plane is doing this, stabilization will make it do that. If you do this and let go of it, it'll right the plane. So it's keeping track of the motion and has to be able to control the servos. But they don't plug into the gyro. If they plugged into the gyro and had a place on the board, I could just unplug them from the gyro, plug them into the board, and all the connections for it would be in the gyro. That is not the case in this application. And what you're seeing is that the servos connect into the board, but so does the gyro setup, which means it's all done on the board, which means I had to pull off this connector, which you can see here, and I have been playing around with this. I figured if I did the same thing where I just pulled the pins out and connected it, it would work. But when I did that, my light stopped working and the board started to heat up a bit. I undid what I had done as best as I could. There's still a couple that are connected, but it started working, didn't heat up anymore, and the light still doesn't come on. Now, I am going to try and remove some of the solder from here right now, and from here, to get this back to a state where it'll be okay. Now, I've looked at this light, and I'm going to zoom right in on it here and see if you guys can see what I can't see, and see, I'll look at the footage after to see this myself. But see, I'm trying to see if this light is popped. It may be, and it may be that nothing I do will cure that. But I'm looking at it pretty close up, and it does look like it's popped. And how you can tell if it's popped is right here. You will see it. So what I'm looking for here is to figure a way to bypass this in such a way that my servos work. So my hope was that when this is bypassed correctly, I can use my servos. Because right now, the servos plug into the board, but the gyro is giving control to the servos. And I can't control my servos, even though it seems like I've bound correctly. It seems like everything works. I might need to go and buy their stupid gyro that I don't want. And if that's the case, I'm not using this board for my build. If I can find a way to do this, it'll work out okay. But the problem there is you need to find a way to do it. So what I'm going to do here is just try and remove some of the solder, guys, and remove the pins, the last of these pins, guys. I want them gone. And you can see, as I'm doing that, they're coming out the back, okay? So I'm successfully pushing these pins. Now I'm going to take the very tip of my soldering iron, and as precise a way as I can, I'm going to try and push each of these pins as deep as they will go through. Okay? And now it would seem that they are as deep through as they can be. Now you might ask why I want to do that. I also want to try and get as much of the solder off of here, guys, as I possibly can. And make sure that the solder is removed from each of these connectors as much as I possibly can. And the reason is I don't want any connection between these. So it may seem silly given what little we've done. The board is heated up a little bit though from my efforts. One of the other reasons that I like to have something like this on hand is because I am about to correct one of the pins. I'll show you what I mean. See on the back here? You don't ever want these pins touching each other. So you do have to be careful. I'm just going to move this over and take a good look with my bare eyes and see if I'm done yet. Now it doesn't look like I am. So here's the part where some pliers come in handy. I'm going to take a pair of pliers of any kind, but I hate to say it, sometimes these are the best ones because as you pull, see the way they just locked? And this comes out. So if I grab tightly something like these pins and then squeeze on them, it's like it wants to rip them right out of the board. So what I'm going to do is I'm going to hold this in place. I'm going to reach up. I'm going to put a little forward pressure on this to put pressure on those pins. And now I'm just going to hold this in place while I heat up the pins and put a little pressure. And they will come right off when they're ready. But you got to heat it right up first. So let me just look, make sure I'm heating the right place. And I need to be heating all three of these pins at once, you guys, or this isn't probably going to go very well. But it's giving me difficulty here. Sometimes it does that. But I also have a very poor... Oh, here we go. So, we're just going to take a look. And unfortunately, I did not get rid of all three of those. And I was really hoping I would. This may be... I was hoping to get rid of all three at once. And if you can't do that, you can always go back in and pull them out individually. However, they might be far enough down now. Oh, I can see why. The tips of these have been folded over, and you got to be careful about that. I've successfully taken most of the solder out, which is good. So these actually look like I've successfully gotten all of the solder off those individual connectors. At this point, all I really need to do is make sure that pin isn't causing any problems, which is where my handy-dandy little tool comes in. Or a pair of pliers. Either one will do the job. But all I want to do here is lay out these pins. In such a way as to make sure they're not physically making contact. Easiest thing to do is to spread them apart. Alright, so now that I've tried that, I'm going to plug this in. Now, I do have a serious suspicion that my light is fried, guys. Always check these. See that? I almost cross-connected it. So, I'm going to turn this on. Watch carefully the remote, guys. See that? It'll turn itself into this mode after a few seconds. This one seems to like to have this plugged in first. And we're touching the board to see if it's heating up. It shouldn't really be. But here's the problem. The light no longer works, and I popped the light. What I did was cross-connect these to try and jumper it, just like I did this one. The problem is it didn't work. What it did was heat up the board a little bit, so I disconnected that and removed the solder, which was all well and good. The problem is now that I've made that happen, I think I've fried my light. Now the light is okay, I don't care about the light, but it makes it very difficult to verify the function of the remote. Except, I know enough about these to know that this should connect pretty much right away with this, if they are truly connected. And there should be other things I can do that would turn the light on and off. But I can't do any of that now. So, oh, it is getting hot. Okay, so that tells me that what I have here isn't complete yet. Now I go and touch here where I had crossed these. It's not hot. Where it is hot is here. That's bad. But in the end, it's actually right here, right where I was working. That is the hot spot. So we knew already that this was a problem. And the reason is once I connected these, it was a problem. But I did sort it out. What I mean by that is it wasn't difficult to sort out what the problem was. I knew it already. And all I want to do is try and remove these pins as best as I can. So if they won't come out one way, I can always put them out the other way, guys. There's always two sides to this. You see how fast that went through? And when I see the pins on the other side, guys, I'll show you how screwed up they are, how bent over they are. Just remember, when you're soldering, there's always two ways to go about things, because you always have two sides of the board. And I know it might sound strange, but that really is the truth. Two sides of the board matters. See that? See how fast the pin popped through? That's all I want to do here, guys, is pop those pins through. And while I'm at it, I'm going to try and add to a couple of these a little bit of solder, because we're about to do an experiment to see. So the reason I suspect this is a problem, as I said, is because this is for a gyro. So now what we're going to do is we're going to put this away. I'm going to unplug it for a minute. And the reason is, now that I've pretty much gotten all the solder off that I think I'm going to need, I'm going to do the same technique, only I'm going to grab from this side because it seems like that's important. And now we're just going to put this over top. See that? How quickly that comes? So we're going to put it right in place, just so I've got grip of those three. See that? And they start to move. And look at that. They come right out. So now, in one fell swoop, we have all the pins out. And so I'm just going to kind of go over this and make sure that we do, in fact, have the pins out. That one looks like there's a piece of it there. Also, now that I'm able to see all of these clearly, I want to make sure that there is clear delineation in between each of these posts, indicating that none of them is directly connected together. Okay, and I want it to look kind of like that, where I'm seeing a separation in each one. Even if you have to carve a little slot on the board, I did that to show you guys. You can carve a pathway to separate two connections if you have to. So now that this is finished, we're going to leave that aside. Now I'm pretty sure I've gotten all these connections broken in the places they need to be, and they're now all individual again, which means at this moment, when I plug it back in, if my light does not come on, it means that I have cooked it. I did look very closely, and you can see the little break right here, which means no big deal, I cooked the light. What I'm looking for here is to see if this works. Ah, look at that. Magic. The light comes back on and it bound. Woohoo. So, here's what we want to do. I need to work out a bypass here. Also, we're going to be checking it for heat because it was heating up, guys. Now, mind you, this is a 350 mAh battery. You might think that's the problem. It's too much power or whatever, but no, it's fine. So, what we're going to do is we're going to teach you how to figure out how to splice this. Now, this isn't a bomb. We're just going to arrange a simple bypass just like we did on this one. So, I've shown you that these things are repairable. If you make a mistake, even one that's heating up the board and looks like it's going to fry it, I caught it right away because I was paying attention. It heated up. I unplugged it. It wasn't rocket science. But for this next step, I need to make good and sure that it doesn't overheat because we're going to need to leave it plugged in for a while we experiment on it. Isn't that crazy? But the light's back. I still have full functionality over the board. That's no joke. I have proper functionality, it would seem, except I have no action from anything. I don't have a motor hooked up. That's not shocking. But it connects, and watch, and it disconnects. Which means this is absolutely working, and these have bound. There's only a couple reasons why this wouldn't work. One is a protocol issue, which is to say that each radio operates on its own unique protocol, and there are compatible protocols. that are designed to work together, and then there are protocols that are not. These two are designed to work together. They're from the same company. They are the same protocol. Now that we fixed this, and I've done it properly, even though it looks a bit messy, I've done it proper. Now what we can do is take a wire after we turn this on, and in the next video, this is what you'll see me do, where we'll experiment with this and find out where we need to connect it to bypass this circuit. And the reason is, as I explained earlier, the servos are plugged into the board here, and then they go through the gyro, which means there's connections that plug these two together. So if I look carefully here at where my servos are located, I need to plug them together. And I bet you money it's these two right here next to each other that need to be put together, because they're ones from the servo pathways from what I'm seeing here. And it really does look like these two. In fact, one of them comes to here and has other traces. Now, there could be other traces on this side of the board. And when you look really closely, it may literally be that all of these are run through those two. Those might be the positive and negative for this. So what I'm going to need to do is to connect those with a wire. And if I'm right, my servos will suddenly start working and it will finish its arming process. If it can't, it's because I haven't wired it correctly. And when I've wired it correctly, it will. But I might need to include more than just two pins. I might need one from here, and one in the middle. And those have to be jumpered together with a wire and some solder. And you can do that just by arcing them around and making a little solder connection on each, and you'll be good to go. I'll show you that in the future. This is coming in the next video, so do like, share, and subscribe, because I've already showed you how to take this, lighten it, and I will teach you how to re-engineer these for your weight considerations. I'll also teach you how to troubleshoot them, how to bypass situations that might be a problem. Hey, if your on-off switch had broken and you were going to throw this out, don't. Take the on-off switch on. Follow my simple instructions. Cross the middle three that are your connectors for a standard on-off switch, and bam, you done it. You can do it on the front or the back of the board. As you can see, they're not connected on the back side. They are connected on the front side. Don't hold your soldering gun too long. You will leave a burn. That being said, it won't hurt the board. I wanted to hack on this one to show you guys. There's a reason I have a brand new one sitting here, ready to go, in case I damaged this one while I was experimenting on it and teaching you guys about how this stuff works. Now, I know you learn all the textbook stuff, and you don't need me to reiterate to you that this is called a circuit board, also known as a PCB. I don't need to tell you the name of this connector. I don't need to tell you how many amps this light takes. Hint, hint, it's less than one. Well, sort of, it's a 1 amp, more than likely. But it does seem now that even though this connection looks broken, I tested it and it works. This is one of the things I wanted to say about engineering. Yo, test everything. You'd be amazed what you can make work. I thought this was toast because I screwed up and it got hot. But I didn't give up. And now it's back to just like it was before I did this, only slightly lighter. And so let's get our final weight, because you might not think I've done anything extra after what I described, but I removed all those pins. That's 5 less pins on the board. And 5 less pins is less weight. That's 0.4 less weight than it was before. So we've removed, that's 0.04. But it does show that we've now removed more weight. And it is now, as I said, it was just barely over 3. Now it's under 3 by a nice little margin. And that is good. You might think I might do something nutso, like shorten my antenna. No, I would never do that. This is okay to shorten. You can down gauge the wires. You can do all kinds of things without giving yourself a problem here. But in the end, this is a pretty resilient type of board. You're talking about an on-off switch. Adjusting that, messing with that, you can't fry the board. This one you could. You do be more careful. This has both a positive and negative that come from the power. It also has the runs for all the servos into it, which means if you really screw this one up and overheat it, you could fry out circuits that would wreck the whole thing. What I need to do is figure out which of these I need to connect to allow my servos to function and skip the stabilization that I don't want. So I'm sure somebody out there has already figured this out. Guys, YouTube will tell you I have not watched any videos on how to do this, guys. Not one. I just know what I'm doing. And I will show you how. So that's about it for this one. This has turned out to be quite a long video, but it's important. In the next one, we will do a bypass. And the reason you guys saw the light was off was I had bypassed it. Here. One of these is for the light. The light runs through it as well because clearly the gyro affects the light. Well, I wasn't seeing any lights from the gyro, but I've been told that there's other colors that can come from this, and I've only seen one. When I skipped this gyro, and look at that, that actually came out really neat, guys, didn't it? It's not that hard. The backside's pretty messy, but the top side, nice, neat, and pretty. You can do it nice and neat if you take your time, guys. That being said, take your time, do your research. If I was smart in doing my research, I'd find out which of these pins I needed to bypass by watching some YouTube videos. But I'm here to show you how to engineer this. Better yet, how to reverse engineer this, how to figure out what to do. Well, we've empirically figured out, even though I didn't look to see, what the problem is and why this won't work, even though it's binded. Why I can't get any control over my servos. Well, then I gave it some thought and I realized what that problem is, and now we're going to solve it. It's as simple as that. It's just like saying, hey, I want it lighter. Now I'm saying, hey, I don't want gyros. Keith out.